Good afternoon, good morning, everybody. We're right before lunch, so I'll try and keep it really interesting. And as Mark said, I'm the president of WhiteStar. I think I was FME license number 7. And Pete has been here 3 years working on a really interesting project for us. I'm a data nerd. We are collecting parcel data from more than 3,000 counties and county equivalents in the United States, processing that into some kind of common schema, and then loading it up into FME Server and AWS so that people can come in and zip, clip, and ship pieces of it. So we're a private company. I've been in business for 30 years and have seen a lot of GIS technologies come, go, and bloom, or not really go away. It seems like they keep popping up out there. So just real briefly about us, the private company, we like to, I really like what ARUP Corporation said in the last slide, we do it right or don't do it at all basically, and we feel that way about data and cleaning it and using FME to validate dates, and we had a comment over here about mountaintops like the Matterhorn that were negative 1,000 feet. I mean, just because data exists doesn't mean it's right, doesn't mean it's validated, doesn't mean it's even useful for any particular purpose, but FME gives you that opportunity to do something with it, to at least know where you stand, to at least know the size of your job, and with 3,000 plus counties, it's a big job. So I like to tell people those little details, and that we also bring digital life to 200-year-old maps. So a lot of the stuff we do is based on old maps and plats that were generated in the colonial times in the United States, and well before there was any concept of real-time coordinates or GIS or anything, obviously. How do you bring that forward into the 21st century? So this particular project, we had the keynote this morning talked about 30 countries in Europe bringing their data together, processing it in a workspace, and sending it on to its just desserts, happy destination. Well, we have 3,044 counties or county equivalents in the United States. I think the only thing that joins them together is sometimes they speak English, and that's it. Every county, unlike in Canada and much of the rest of the world, is free to define its own standards. What does it mean? A parcel, accuracy specifications, technologies. So FME is a perfect technology for bringing CAD data, DGN files, shape files. I found out this morning Shapefile had a Twitter account. That was a great takeaway. Anything you can imagine gets brought together inside of FME. Building all kinds of tables to normalize and standardize the data as much as possible, and get to a release 1.0 at least of all of these millions of polygons stored in the cloud and available to FME Server. And then also, this is a big deal. People care a lot about a version of the polygons this year and the version of the polygons next year, and what has changed, what's growing, what's getting subdivided, what's getting platted. This little map on the right gives you a little bit of a graphical understanding. The lines in gray are the parcel data. So if you own a house in the US or Canada, it's probably located on a parcel similar to this, the little gray polygons. And in the US and in much of Western Canada, they have what's, in the US it's called the Public Land Survey System. In Canada, it's the Dominion Land Survey System. And it's sort of an intermediate permanent reference system that is the basis for all real estate, oil and gas, forestry mapping. Here in BC, it's a little different. And in Quebec and the Maritime provinces, it's a little different. And in the original 13 colonies, it's a little different. But a big chunk of North America, US and Canada, use the orange squares that are numbered. So this is a little piece of California just south of San Francisco Bay Area. So I wanted to give you some feel for the size of this project, what's involved. And with that, I'm going to turn this over to Pete, and he's going to talk some more about the details.
Yeah, thanks, Robert. Yeah, if you're interested, Clint Eastwood lives right about here. So, as you know, and as Robert has indicated, there's some real variable sources out there. There's some counties that don't have digital data at all. where we have to go and grab their plat maps and put them together along with their tax assessor data. And then there's some states actually that have good statewide parcel data, but still need some massaging to get them to the point where we're really providing value for them. And even state, city, and zip, you can't find that in a full address all the time. You know, like Arkansas, just leave out Arkansas because it's repetitive for them. So you got to kind of add things in, take things away. So just get an idea of our schema that, you know, we're building upon kind of daily until our 2017 release. We try and grab as much attribute information as we can, including now district information and valuation in terms of land, structural, and total value. Acreage, of course, is you can get the actual published acreage or use GIS to figure that out. But I think the hardest thing that we've had to do lately, our original schema had us break up or deconstruct addresses into its various component parts. So you had like a number, then a direction, then the street name itself, a suffix, a post direction, apartment number, etc. And again, these vary pretty much even within the same state. So how do we deal with, you know, we're going to try and make this sound sexy and make it, you know, how do we deal with string theory, basically? So, you know, you've got so many ways addresses are written because there's so many people doing the data entry and not following any particular standard. So I'm going to go through some transformers that help us out with that. Any string transformers that provide regular expressions using the regular expression editor. How many people use that? Okay. Good smattering. So, you know, primarily using the string searcher, the string replacer. We also create different attributes and trim attributes where necessary. Another really handy tool that we've used is the Inline Querier. And with that, you know, I'll go into an example of that in a second, but here's an example of some test filters we've created. And if you wanted to kind of just generally specify what regexes you want to use on each line, you can do that. You could also use the regular expression editor to generate, you know, kind of a more complex kind of gobbledygook statement at the top, you know, which I thought was gobbledygook at first. But you can use the quick reference guide, and as you type examples down in the test string area, you can change the above regular expression just to make sure you're getting the selection you want versus what you don't want.
This is a really good tool. I mean, I use it even on non-FME projects. Regular expressions are a really great way to standardize and clean up data, whether it's an address like this, or we have oil and gas data sets from the states and they spell the operators all different ways. So it's like super powerful, but it's kind of not talked about a lot. I mean, it's used, and this supports the whole suite of what Tickle's implementation of regular expression?
I believe so, yeah. So yes, it's become pretty valuable in terms of dealing with variability in how people designate certain things like, you know, certain street suffixes, etc. in this example. So you can get this from our slide deck, but here's some favorite kind of how to use regular expression sites that I've indicated here. There's also, it's getting cut off a little bit. Instead of angular expressions, it's regular expressions. An O'Reilly book that has a cookbook for saying, you know, I want to do this and that with a regular expression. Point me to the design pattern for that.
And if you have any insomnia problems, that's a good text as well.
I might switch it on. Okay. Oh, it's on? Okay. So, the Inline Querier I mentioned before, this ended up being the most powerful tool for extracting things like city, state, and zip from a full address file. So we take one data source from the post office, and the other source is the full address string of the owner, and we basically write a little select statement from there, and when you use the like clause or whatever, you can look at various different things no matter where it is in the source expression. So, you know, in some cases we're looking for, like I said, some places have the city, state, and zip, so we kind of combine that into a substring, or the city zip and combine that into another source string, and you know, basically if there's a match we pull those out. So as we do an address, we're kind of taking the beginning and kind of try and get so many attributes from the front of the address string, and the city state zip is usually in the back end of the city is of the address string. So, you know, basically if you've got First Street, St. Stephen's, Colorado, you know, you're grabbing that St. Stephen's out as opposed to, you know, what street, what ST do I necessarily need to grab. Secondly, we merge the owner and any other attributes with parcel polygons, and also join, if we have to, between the parcel ID and from each of the two sources, whether it be a tax table or a shapefile or wherever else we're getting our geographic information. So in merging the data, a lot of the data we get is a little bit sloppy, you know, for the most part. So we run the geometry validator against that. The spatial relator is used to, if we have point data, to join the attribute data with the boundary of the parcel that it belongs to. We use the list explorer because you might have to join or build several polygon layers for things like townhouse parcels, stuff like that. So you might have 10 owners, and so you want each of them to have their own representation in the database.
And Pete, we run into a lot of people who want to just take data from the raw source and put it into FME Server. Comment about the geometry validator, and it won't work because the lines self-intersect or have some other geometry error. I don't think a lot of people realize that, you know, you just can't necessarily take raw data and expect it to work, because, you know, if it's a CAD file, there's nothing wrong with having a self-intersecting line. So yeah, but it in Esri world and an FME world, you know, so it's a really important point. People build entire business plans upon using raw data, and good luck. Yeah,
not only do you have string theory, but you have like free radicals that get in the way of things. So again, we might have other attributes that we can add value to what the county provided. So we use the free feature merger for that. So, you know, we pick a common attribute like FIPS code and add on some other columns that may not have been there originally. So here's an example of using the Spatial Relator with the list exploder. We take everything out of the list exploder and we find out if there's any duplicates, and we filter those out, and then bring them into the FIPS code feature merger that's derived from a CSV file that assigns FIPS to every county. So change detection, kind of the last value add that we provide, along with just making it available to our customers. We try and detect differences against the last release, but it's impossible to kind of do that for every variable and still be sort of meaningful. So as far as the geometry, anybody who's worked with reprojectors and so on, a lat long will be like 10 decimals deep. So to really find out if something's actually moved or expanded or contracted, we round off those point values and polygons, centroids, etc. With the variable setter, we set a baseline date, and then for geometry changes, we create a matcher that looks for those and then updates the date accordingly. And another matcher for detecting general attribute changes. Not every one, but if an owner address changed or an owner name, etc.
Yeah, I want to point out that any GIS data set, we believe, should have both of those, right? Because sometimes you care about the geometry change, sometimes you care about the attribute change. And it's kind of amazing when you look around the world of GIS data, unless you can tell what changed, it loses half of its value. So that was something I didn't think of, but a customer told me one time, hey, we really need that. So,
Yeah, so we put
important.
it pretty much on everything we develop or put out there, whether it be higher level land layers or well data, etc. This last item here, the Workspace Runner. How many of you use Workspace Runner? Okay. About the same amount of use regular expressions, but a little different hands that went up. But anyway, we love this thing for batch processing. So, let's say we just want to do all the counties within a state. We'll pick a variable here, and like in this case it's FIPS, since that's kind of a numeric unique value, and run the all the processes that we put together before for feature quality correction, parcel and attribute merging, and then change detection. We run all those through this Workspace Runner, and it provides good summary information in case there's errors along the way, and you can revisit those processes. But here's an example of how we specify variables within there. So you enter your FME workspace that you would just want to run and throw variables into, and then you define things that the readers and writers need to look at, but instead of explicitly providing file names, you're adding variables to that. So we're using like the FME calculated directory, and we're using the value of the FIPS code in terms of feature types to read. And so we output basically one table in PostGIS for every FIPS code using this runner. And like I said, I kind of like it better than just running it in the command line, because you get a little bit more status that way. Well, that's about all we have. You know, hopefully the string theory and the free radicals, you know, were talked about enough so that you can go write a science paper. Is there any questions?
How often is the data refreshed?
How often is the data refreshed? In our case, we try and visit or touch each county once a year. So at the end of the year, we kind of release as fresh batch as we can. For a lot of the counties, we're striving for all, but mainly the counties that our customers are interested right away.
Okay. The reason I ask is the organization I work for, just within BC, we collect cadastral data. When we get a rate from our custodians on a weekly refresh, so our consumers know that the data is current within a week. We don't have control over when they do the edits, but if it's done, it's caught up with ICI Society within the week.
Yeah, I really admire the municipal infrastructure of Canada in terms of, you know, being able to, you know, kind of spec from top down and bottom up what's going to be provided, you know, in real time or near real time.
Yeah, and we get it. We just get them to throw it over the fence. We respect like what the data models that they're working in, and then we do the ETL on our side using FME once it's up to us.
Yeah. In the U.S., a lot of counties are lucky to update their data once a year. It's, if that, I mean, because that's when they assess taxes.
Oh, okay.
But we also have to look at those rural counties, you know, for applications like wind and solar, et cetera.
Thanks. I had one question about your change detection, whether any counties are giving you history data and actually giving you that change for you, or, you know.
No, we're making it. Maybe we can sell it back to them, but it's just in the raw data, and since we've been doing it with the change, FME change detector.
Yeah, again, for some cities, it might be that way in terms of how sophisticated their GIS crew is, but again, for the medium to small population counties, it's rare.
Yeah. There was one other question.
I imagine this doesn't come up too much within the county itself, but if you get data when you get data for counties next to each other and say they may overlap one way or the other, how do y'all determine who wins in that situation?
This release 2.0, right?
Yeah. Well, right now we just, you know, we sell the data primarily by county. So it's whatever that county has absorbed into their sphere, you know, and if there's adjacent counties, there might be duplicates, there might not.
Yeah, I mean, the conflation and edge matching and all of that is a monumental task, but it is one that, you know, we'll be here long enough to address it. But yeah, good question.
And a lot of counties go over a lot of parcels go over county lines, so, you know, there may be some tug of war between them, I'm not sure.
Any other questions for Robert before we break? Okay, thanks very much. Thank you very much.